Hello and welcome to Code with JV. Today, let's talk about Git and GitHub. Outside of the fundamentals of programming, terminal skills and Git skills are the two tools you really need to be an effective programmer. You can write a bunch of code without knowing Git. It's just a really useful tool for managing your code as it changes over time, and particularly for collaborating with other people on writing code together. In today's video, I'm going to show you the key mental model for understanding Git and how it works. We're going to play with some basics in the command line. I'm going to show you how you can use ChatGPT and other AIs as a tutor to teach you Git, and we're going to do some basic things with GitHub. Let's jump into it. Two reference things for you. There'll be links below. This is the Git book, and this is like more than you need to know about Git. It's a really good reference source, particularly if you're using ChatGPT to test that it's teaching you the right stuff. GitHub also has excellent starting points, and they go not just into Git, but GitHub itself. Because one thing to realize is Git, it's a vanilla command line program. A way of formatting a metadata folder of all about the changes in your code so that you can track those changes yourself and share those changes with other people who are using the same tool. GitHub is a website that was built after Git and as a way of acting as a place for people to share code online with each other. ChatGPT, excellent at teaching you Git. It knows a lot of this stuff. I'm putting a lot of stuff up on GitHub as a very natural way to share things, because when programmers write code that they think, oh, I want to share this code with other people, even if that code is just markdown files or documentation, typically we'll reach for GitHub, put it up there because it's free for anything that's open source. Here I've got my AI tutor guidelines, copy paste. I have gone and created a sample module for learning Git. We can paste that in. It's got some basic things in here, but you can paste in this module. If we look at the activities, you'll see activity 1 is just an overview, installing and setting it up, creating your first repo, basic commands, understanding branches. You can start to go in here, teach me activity 4. It will start to walk you through the changes. You can ask questions. There's lots of things you can do with ChatGPT. So what I want to start with was the simple mental model of Git. Here I have a terminal. It has got a single file in it. This file is just a text file, but so is all code. We're going to take a quick detour. Let's learn about diff files in your terminal. If we have two versions of this file, now I have two files. They're exactly the same. If I go diff file.txt, file2.txt, it's going to show me no output. These files are not different. They're the same file. Let's go and edit file2. I'm adding something on the end. Now if I run my diff command, it will show me something like this. It's showing me the difference between these two files. The purpose of Git is to track the changes of files over time so that you can share your changes with someone else's changes and merge them in together. If you just change the text file itself like this, and I go and some new things, etc., and I save it, I make some new changes, save it again, there's no history of my changes. Text files don't come with history baked in. So you can think of it a little bit like Git is a way of giving a text file a very detailed history log of how it's changed over time. If you start to think about having versions of a file where, okay, we can see that the difference between file 1 and file 2 is it's got some new text. Copy file 2. Let's make it file 3.txt. File 3, I'm going to remove a line. And now if you do diff file 2, you'll see this is what it looks like when you remove something. Let's do one more. I'm adding and removing. So now diff file 3.txt and file 4.txt, you can see that you can have this deleting and removing in the same thing. And this is what's known as a diff file. I've got 4 different files here that have changed over time, and I don't need to record the whole file structure to maintain the change log. I can just have my starting file and all the changes. And it's a more efficient way of storing everything rather than having a whole copy of every single version at every stage. So if we do something like this, diff file, and let's get to file2.txt, if I put a -u on it, it changes the format a little bit, and it basically gives it a little bit of some metadata around like what files, when, where has it changed. I'm going to put a -u in there, and I'm going to call this change1.diff. We can do this for every single change we've done. If we go cat star diff, we can see this is what they look like. We're having a look at the changes here and the changes here and the changes here. So it's tracking the way this single file changes over time. I know we haven't touched Git yet, but hopefully this will help you have a really clear mental model of how Git works. Here, I can actually remove file 2, 3, file 4, because the information to regenerate those files exists in the diffs. If we look at file.txt, it looks like this. And this was our starting one. If I go patch file.txt, and I'm going to go change one.diff, you'll see it's now changed to the next version. And we can keep patching it, change 2.diff. And now we can have a look at our text file. And it's got all the things. We've got the delete, we've got the extra add. We've regenerated it at any stage of its history. You can also go backwards, patch -r, file, change 3.diff. Now we have unpatched it, essentially. We're now at version 3 of the file. When you're working with Git, it's doing all this stuff under the hood for you. All you're doing is saving your changes as you go. It's a much nicer interface, but really it's just lots of chains of these diffs, and applying them forwards and backwards is not everything Git does, but it's a big part of it. One last point. Notice how I said with the starting file and all the diffs, well, Git actually doesn't have a starting file. Touch empty.txt, and we go diff empty. Oh, my file is out of sync. I now need to unwind it. So patch -r file.txt, we need change 2. Patch -r file, I want change 1. Cat file. Now my file is its original one. Now if I go diff empty.txt file, this is just like creating the file in the first place. And I can chuck a -u start.diff like so. And then with just these diff files, start and change 1, change 2, change 3, I can regenerate any stage of my history. Building up this chain of diffs is what Git does. The key metaphor to have for Git is that each one of these cards is a diff, and in Git that is called a commit. You build up a chain of changes on your files, which can be adding files, deleting files, moving things around. Any change you can make to a code base is encapsulated in these commits. And a bunch of them together is a way that you can jump between different versions. So you can go back to a particular version of your code. Right, so let's take this code and set it up in a Git repo. If I go git init dot, what it's doing is it's making a .git folder. That .git folder enables Git. It's really common to have your branch called main, though the version of Git I'm on is calling it master. I'll follow convention and call it main. Now you'll see the red dot means we've got a bunch of files here which haven't been saved. They're not in Git. I can't track the versioning of any of these files here. What I can do is let's add them. Now, when I add them, it hasn't made a commit. It hasn't packaged them up into a diff. It's just got them ready to. And this is called staging your changes. You're getting a bunch of changes and you're saying, I want these to be saved when I do my next commit. I could say, oh, what's this new file stuff? Reset, new file. If I do a commit now, it'll just save these files, but not that one. So you can be very precise. If you've made lots of changes, you can start to package up certain slices of them. A good rule of thumb is you want to make small changes and save commits as you go, rather than doing 2 weeks of work, one monster change. It makes your life harder in lots of ways. Small commits is a really good habit to build up. Let's commit this now. I'm going to go starting code. Now, if I do a git status, it'll just show me what's different between this and what Git knows about. Git log will say, this is my first diff. This is the code we've done. If you do a git log -p for patch, it will show you, hey, this looks like those patch files we saw. You can start to see the actual code which has changed, what lines, etc. We saw git init for making your repo. We saw git add, getting your code ready to be saved, git commit for actually saving it, and git log for having a look at them, and git log -p for having a detailed look at the changes. Let's go git add new file. And now I can do git log. I can see the history of git commits we've made. We've added another diff in, because you can start to do things like, okay, git log. Let's grab that ID. git checkout, paste the ID, and now I am no longer where I was. My code has changed. You'll see there's no new file.txt in here. And if I go git log, I can't even see that last commit. That's what checkout does, is it moves you into different states in your code base. If I'm in here and I want to get back to where I was, well, the branch was called main, and now I have gone and I'm back and I can see the whole history here. If you type git branch, you can see all the different branches. When you go git branch, new branch, like so, I have now got another branch. I have made a copy of it. Let's go and look at our new file.txt. So I'm just adding some changes to it, git status. You'll notice that when I made the new branch, this didn't change. If I go git checkout, new branch, now if I commit it, I'll be making the change to this branch. If I committed it here, I'd be making a change to the main branch. Git add, like so. And now git log, we have got ourselves a third one here. What I've done is I've made a new one of these, except it only exists in this new branch. I can go git checkout main. I've moved my focus up to that top branch, git log. We can just see those ones there. This is where you can start to have different versions of your code, where you might be experimenting with a new library or adding a feature, or have your production branch, or you're testing all sorts of things. Having branches of your code is a really useful thing to be doing, because you can start to do some quite powerful things. Where I'm on my main branch, okay, so we've got our new file.txt, and in my main branch, I'm going to git add, like so. What I've done is I've gone and made, we should call this C, shouldn't we? So I've gone and made another commit here, and you can start to have changes happen in parallel. And this is also where the complexity of Git comes in, because how do I merge those two things together? Well, it's a command called merge. Git merge new branch is going to say, take all the commits that are in new branch, bring them into this branch here. If the computer can figure out how to merge them unobtrusively, it will do so. If it can't, it's going to say, hey, we have a merge conflict. And now this is non-basic Git stuff, but essentially what it's saying is there's a change in the files here. You both changed this new file. I couldn't figure out which order to do them in. Now, if I go git status, you'll see this sort of thing. You have unmerged paths, fix the conflicts, then run a commit. You've both modified this file. Let's have a look at that new file. It's basically saying, hey, you made this change. The other branch has made this change. I don't know how to reconcile them. You can start to think about how you want to do it. It's saying a human needs to come and intervene. You can get both of them. You can start to choose one over the other. It's your call. But then what you do is you get your code in good working order, git add new file, resolving merge conflict. Once you start having lots of different branches and merge conflicts, don't be scared, just go slowly and start to understand that, hey, that's just the computer couldn't figure out which order to do them in. I've made another commit. And now you can see the Git history. Here's the starting code. Here's my first change. Oh, here's the change that happened on new branch. And you'll see this is where the pointer for new branch is. It doesn't know anything about these other ones. And then here's where the change from main happened. And up here, this is a new commit which resolved the conflicts and merged them in. This is where your main branch is. Just to upgrade our picture of what went on there, my commit went and did this. It took a version of this and put it here. And then let's call this E resolve merge. It just extended that history there. This is what it means when it says that head is pointing to E for main and the new branch head is pointing to C, because it doesn't know about D or E here. We've done quite a lot here, and this is getting a bit further than the AI tutor ones I gave you. It doesn't talk about merge conflicts, and typically it's not the sort of thing you'll learn about straight away, but I just wanted to give you a heads up in one video about, hey, this is what merge conflicts are, here's how you can resolve them. Let's learn a little bit about GitHub. One of the things on GitHub is you might find repos that you want to follow. Code with JV, learning plan starters. This lives on the Code with JV organization. If you find an open source repo that you want to change or contribute to, one of the first things you want to do is learn about forking. So forking says, hey, I want to change this and I want to create a copy of the whole repo, the whole folder, all of the history, all of it, and I want to put it on my personal account. And that's what it means when there's a fork. It means someone has forked that repo. So you can copy just the main branch or untick it, and you'll get all the branches that exist on that repo. I just want the main one for now. When I have made a fork, I have gone and made my own version of that repo, which lives on my account. You make changes here, it doesn't go back up to the other person's account, because typically the person who owns the code base would want to consent before they accept random people changing the Git history. What we can do here is once you've forked a repo, for example, say you have your own learning plan and you want it to go into here, which is what I'll demo now, is that learning plan I pasted into the AI tutor. Well, we've got Markdown, Python, HTTP, terminal stuff, nothing about Git. Let's make it. You can get this URL, and here I'm going to go up into a new folder, git clone, paste the URL of your URL, and now what I've done is down here, I have now got a whole copy of that code base. And this git clone, get a copy of a code base, this is why developers love GitHub so much, is you can just grab projects and change them and do all sorts of stuff. I'm looking at the convention, I've got a folder per learning plan. So make dir git intro. I think I've been calling them module and course, etc. So if I copy the learning plan I created, and this is what I typically do when I am saving learning plans into this repo, is I will make a new file, cat module1. Now, git status, I have got untracked changes in this folder, because if you remember, I made a git intro folder. Git status, it shows me, oh, git intro, the whole folder, that's new. Git add, git status, now it's ready for staging. So again, just the repetition of this is you make changes, you add them, you commit them. I am going to say something like, what am I doing? I'm a sample like so. And so you can see this is what the sample plan is. This is the terminal one that I added recently. So now I've committed it, but it only lives on my local machine. It doesn't live on GitHub yet. And even if I go to my learning plan starters here, this one up on GitHub, my changes aren't there. The last change was 2 weeks ago when I did the terminal deep dive. Because I've just made the change on my local computer, to get it up onto GitHub, we use something called push. Because when you do clone, it makes a remote for you called origin. This origin here, this is where when you do a git pull for copy the code down from origin, or a git push, send it up to origin, is the way that you can push and pull code to remote hosts. So if I go git push origin main, it's taking my changes, my diff, sending them to GitHub. Once you see things like this, it's saved it. Now if I refresh the page, hey, 9 commits. Last one was a minute ago. Here's my sample learning plan. What you can do is you see this has got commit is one ahead, contribute, open a pull request. Again, you can do this in the command line, but I suggest just do it through GitHub as a good way to start. And this is a way of saying, hey, person whose repo I have copied, I have made a change. Will you accept my change? Create pull request. Pull requests aren't a Git thing. They're a GitHub thing. Up here, it's made a formal pull request. And you'll notice it's switched me over the Code with JV repo, where I can now go into it as the repo maintainer. Oh, some random person has made some changes. You can look at the commits. You can look at the files that are changed. And they can start to say, do you like these changes? Do you want this in your code base? If so, you can go, yep, I'm happy with all of that. Down here, merge pull request. So that merge command I showed you where you're copying code into there, this is copying code from someone else's repo into your repo in GitHub. I'm going to merge that, confirm merge. Now I have successfully made a pull request and merged it. The learning plan starters repo, which is linked down below, has got this Git intro. Did I get the links right? Should have tested that. There we go. But that's a really quick overview on Git. We went into quite advanced stuff you wouldn't typically see in your very first intro around particularly merge conflicts and around pull requests. So that's two things which are quite practical to help you get started. But again, ChatGPT knows about a lot of this stuff. It can really help you learn the things you need to learn. Git's a super powerful tool. And hey, shout out if you've got any questions below. I'm happy to do follow-up videos or deeper dives on this, but Git's one of those things where just getting a little bit of it can really unlock a lot of your ability to copy other people's repos. If you want to get local models going, or if you want to find open source code and have it running locally, the whole world is at your fingertips once you start to understand Git. And hopefully you've seen how you can start to make changes to that code and make pull requests to make it better, because it's lots of developers chipping in with little changes, which has built so much of the stuff that we use. Open source is just a very powerful tool, and it's all built on top of Git, and a lot of it uses GitHub. All right, that's it for today. Sign up on codewithjv.com/newsletter if you want weekly updates. Hit that subscribe button, give the video a like, and I'll see you next time.